Hello friends, let's talk today about cytology, and I would ask you to draw along with me because it has been shown that if you can draw something you understand it better, and even better if you can draw it and explain it to somebody else, then you super understand it very well. This is all aimed to help you before you get into the cytology laboratory. The first thing we have when we have a cytologic specimen of any origin is we have to determine whether it is inflammation or whether it is neoplasia. The way we recognize inflammation is if there are neutrophils, macrophages, bugs, lymphocytes and plasma cells, and sometimes you'll see some spindle cells. Because all of these together would be seen with something like an abscess. You won't always see spindle cells, lymphs and plasma cells, and you won't always see bugs. But the main thing we look for are neutrophils and macrophages. And then sometimes other inflammatory cells might creep in there, like eosinophils and mast cells. We have three major tumor types that we can look for if we think that we have a neoplasm going on. The first one would be round cell. And round cells are, as the name implies, generally round. The main thing about round cell tumors is that they have a distinct cytoplasmic margin. That will be in contrast in specific to mesenchymal cell type tumors. There are 5 types of round cell tumors: lymphoma, in which the cells will look like lymphocytes from a blood smear, but may have variable phenotype to the nucleus and the size of the cell. Mast cell tumor. That one will have a round oval nucleus, if you can see it, and then this is the time to break out your markers and make a very pretty purple dotted cell, because that's the mast cell tumor. Histiocytoma, and that one will have a characteristic quote and unquote fried egg appearance, and it often has a prominent nucleolus. It can also have the so-called buttocks phenotype because the nucleus can sometimes look a bit like a bum. And then there's plasmacytoma, which will be an oval cell with an eccentric nucleus. Sometimes, if you're lucky, there will be a clock-face nucleus and then a paranuclear clear zone for the Golgi zone. And then there's the TVT, transmissible venereal tumor. This can look quite a bit like a histiocytoma, and they often have an oval nucleus, but the main feature about them that is diagnostic is this clustering of discrete clear vacuoles at the cell margin. Like I said, lymphoma will have an appearance that might look just like a lymphocyte in a peripheral blood smear. There may be prominent nucleoli. There may be differences in cell size, and there may be differences in nuclear morphology. Sometimes they'll have bizarre nuclear shapes. So that is round cell tumors. Mesenchymal cell tumors include spindle cell tumors or soft tissue sarcoma, and they are recognized because they have quote and unquote trailing wispy cytoplasm. They may have a central oval nucleus. Very frequently their nuclei are oval. They can have fine chromatin, which means it's open and being read, and they can have a prominent nucleolus or even multiple nucleoli. They may also have the so-called caudate phenotype, caudate meaning tail. They will have this trailing wispy cytoplasm and an eccentric nucleus with this tail of cytoplasm. And epithelial origin tumors. Think back to histology. These are tumors that should be sharing borders. Oftentimes we will see epithelial cell tumors where the cells are fragile unless they are contained in a sheet. And so they can be challenging to tell apart from these other types because they will have funny looking cytoplasmic margins. But if you see things in sheets, they can be cuboidal, and you'll see that they will be sharing cell borders with desmosomes, hemidesmosomes, and these are observed on cytology as a clear zone between adjacent cells. Sometimes they will have a larger cell appearing. Nuclei can be any size and position, but they're often round oval, and nucleoli may be apparent, may be very large, and there may be other criteria of malignancy, but you want to see a sheet of cells. Those are the three basic types and how to identify them. What about criteria of malignancy? Well, oftentimes neoplasms have a bunch of aberrantly growing cells, obviously, so they may have abundant exfoliation. Number of cells that we're seeing, healthy tissue doesn't tend to release cells. This is not true for all types of neoplasms. If we think of mesenchymal cell tumors, some types of this population will not yield much cells because they laid down scar tissue, so they don't have much cellularity. But number would be one of the features. And then variability in cell size. Are some small and some really large? And then nuclear size. Are there some giant nuclei in there? And is there a difference in nuclear cytoplasmic ratio from normal? A lymphocyte typically has a nucleus that takes up about this much space, but is it all of a sudden taking up a larger space? We can also have differences in nucleolar size. Then we can think of things like nuclear molding. That is where an adjacent cell has stopped respecting its growth boundaries and has grown fast and is impinging on an adjacent cell, and so the cell nuclei appear to be spooning. Sometimes it will be in the one cell will have multiple nuclei that are all mashed up together, and that is also nuclear molding. And then we can have mitotic figures, an increase in the number of mitotic figures, and then they might start to look bizarre, like we should have equal division of chromatin in the normal cell, but if we start to see tripolar mitotic figures, 1, 2, 3, that would imply unequal division of the chromatin and into daughter cells. And we may also see things like lag chromatin, fragments of chromatin that have been abandoned in the cytoplasm. Those are some ways of doing cytology. And this is all to help you before you get into the lab and begin to look at samples by yourselves. Have fun, friends.